In this video, we'll talk about applications of properties of quadratic function. We already talked about vertex form of a quadratic function, which is here. This form carries a lot of information about the graph of the function. For example, the vertex, axis of symmetry, opening, range, as well as extreme values, either maximum or minimum value. In this video, we'll pay a bit more attention to the extreme values, as they will be very useful when solving some optimization problems in the next video. So, since the vertex form gives us a lot of information about the graph of a quadratic function, we may want to change the standard form of a quadratic function to the vertex form. Let's see this process in the general case, starting with ax squared plus bx plus c. We're going to employ the completing the square procedure. So what would be the first step? As you remember, for easier calculations, we would like to get rid of the leading coefficient first. So we could, for example, divide the whole equation by a. The left-hand side will be f of x over a, and on the right we have x squared plus b over ax plus c over a. And then what's our next step? Well, we are looking at the first two terms that include x's, and we try to complete the square for those terms. So we place a bracket. In a bracket we are taking the x, we are taking the same sign, and we are taking half of this middle coefficient, which is b over 2a, right? Now, after squaring, we need to subtract perfect square of the number that we took in a bracket. So that would be b squared over 4a squared. And then we copy the rest, so plus c over a. Let's rewrite the left-hand side. F of x over a stays here. In the next step, we would like to combine these two fractions under the common denominator. So to bring the c over a to the common denominator 4a squared, we multiply the top and the bottom by 4a. Therefore, we have x plus b over 2a squared, and then if we want to keep a plus here, we're going to write this minus just by b squared. So our common denominator is 4a squared, and in the numerator we have negative b squared plus 4ac. Let's finish the left-hand side. It's f of x over a again. So we're nearly done. What's left to do is to leave the f of x by itself, therefore multiply the whole equation by a. Okay, let's write it over here. Our f of x is equal to a times this bracket, so a and a bracket, x plus b over 2a squared. And then if we multiply this fraction by a, this a will be cancelled with 1a in the denominator. So we get plus negative b squared plus 4ac, that's the same, over 4a. And this is already the vertex form. We can do one more thing. We can rewrite this function in equivalent form, but such that it will show x minus something. If we want to keep minus here, the something will be negative b over 2a, isn't it? Okay, so we have this pattern x minus certain number and then plus some other number. One more thing. We could pull the minus out of the numerator, and then in the bracket we have b squared minus 4ac, change in sign, right, over 4a. So let's conclude that the vertex of a parabola ax squared plus bx plus c has coordinates, and this is the first coordinate, negative b over 2a, and that's the second coordinate, negative the whole bracket over 4a. So generally, if we have a quadratic function given in a standard form, we can give the coordinates of its vertex using the values a, b, and c without going through the process of completing the square anymore. Now, since this expression b squared minus 4ac plays quite important role in studying quadratic functions, for easy reference it is denoted by the Greek capital delta and called the discriminant. So we could rewrite this formula for the vertex in a form negative b over 2a and negative delta over 4a. Another way of finding the vertex is as follows. If we already figure out the first coordinate, negative b over 2a, the second coordinate could be calculated just by evaluating our original function at the point negative b over 2a. That will also give us the second coordinate of the vertex. Okay, so we have three versions of a vertex formula that we can use. Now, if we know the vertex, we can write an equation of the line of symmetry of the parabola. Remember, that's the vertical line passing through the vertex, which means its equation is x equals the first coordinate of the vertex. Therefore, it's x equals to negative b over 2a. Let's use these formulas. In this example, we want to find the discriminant, this delta value, vertex, shape, opening, and x-intercepts of this parabola. Then we want to give the vertex form of the parabola and graph it. Notice that the question asks us to find all those important features of the parabola before rewriting it in a vertex form. So let's start with the discriminant. Discriminant delta equals, remember it was b squared minus 4ac, and those are our coefficients a, b, and c. So b squared minus 4ac gives us 8 squared minus 4 times 2 times 5. That gives us 64 minus 40. So it's 24. If we already know the discriminant, it's easier to calculate our vertex. The vertex has coordinates negative b over 2a, so in our case it's negative 8 over 2 times 2. And the second coordinate is negative discriminant, which is 24 over 4 times a, so 4 times 2. Let's simplify this. We have negative 8 over 4, so it's really negative 2. And the second coordinate is negative 24 over 8, so it gives us negative 3. The vertex is at the point negative 2, negative 3. We can visualize this in the graph. Negative 2, negative 3 is here. That's our vertex. Okay, let's write V in front of it to indicate vertex. Now, what's the shape? Well, the shape is of the leading term. So, shape is of 2x squared, which means that our parabola is quite narrow. What about opening? It opens up, just because the leading coefficient is positive, right? Now we need to find x-intercepts. Those are the points with y-coordinate being 0. Therefore, we really need to solve the equation 2x squared plus 8x plus 5 equals 0. Since this quadratic trinomial doesn't seem to be factorable, let's use the quadratic formula to find our x-intercepts, the first and the second. So the quadratic formula goes like this. Negative b, which is negative 8, plus minus square root of delta, the discriminant. So we already have the discriminant, it's 24. As you see, having discriminant makes it easier to calculate the roots. Okay, over 2a, so 2 times 2 is 4. And let's simplify this expression. That will be negative 8 plus or minus 24 is like 4 times 6, so we can pull 2 out of the radical, and 6 stays under. Everything over 4. Now we could factor the 2 from the numerator, leaving in a bracket negative 4 plus or minus root 6. Everything over 4, and after reduction by 2, our roots are negative 4 plus or minus root 6 over 2. So those are our x-intercepts. Now let's graph the parabola. We already have the vertex, we know the shape, the arms are going up, so we go 1 across, 2 up, and 2 across, 8 up. So it's 2, 4, 6, 8, the point is over there. And to the left, 2 steps across, 8 steps up, another point that belongs to the parabola. Okay, let's connect these points. It goes somehow like this. And those are our roots. negative 4 negative root 6 over 2, and this point will be negative 4 plus root 6, everything over 2. Obviously, we could plug those values to the calculator and estimate them, but it's better to have the exact roots. Finally, let's give the vertex form of our parabola. So the function f can be written as a, which is 2, then bracket x minus the first coordinate of the vertex, which is negative 2. So since we have minus negative 2, we can write plus 2, and then plus negative 3, so it's really minus 3 in the end. That's the vertex form of our original function. Notice that we obtain this form without using the completing the square procedure, which means there are at least two ways to obtain the vertex form, either by completing the square or by using the information about the vertex. Let's recall what we know about the number of x-intercepts of a quadratic function with respect to the discriminant delta, b squared minus 4ac. If our discriminant is positive, then we have two different x-intercepts, and the formula for those intercepts is negative b plus or minus square root of delta over 2a. To visualize this situation, let's see how the graph of our parabola may look like. It may have arms up or down, but in both cases, the graph will cross x-axis twice. We have two roots. Now, if the discriminant is equal to 0, then we have exactly one x-intercept, just because this part of our formula will disappear, that will be 0, right? So this one root will have a formula negative b over 2a. The geometrical visualization goes like this. Our parabola will barely touch the x-axis in exactly one spot. Finally, if the discriminant is negative, we don't have any x-intercepts. Why? Because root of a negative number doesn't exist in real world. It is an imaginary number, but we are searching for real solutions. Therefore, the geometrical interpretation of this situation will be our parabola is apart from x-axis. It doesn't touch it at all, right? So those are the three situations. The value of the discriminant tells us a lot about the nature and number of roots. Now, for each function, state the number of x-intercepts, the shape, opening, and the vertex. Then graph it and state the extreme value. Here we see our vertex formula, just in case we want to use it. The first function is x squared minus x plus 1. So, to state the number of x-intercepts, we don't need to calculate those x-intercepts at all. We just need to calculate the discriminant, isn't it? Because this will tell us how many intercepts should we expect. And this will also help us to find the vertex. And that's all what we need in order to graph it. Okay, the discriminant is b squared, which in our case is negative 1 squared, minus 4ac, so 4 times 1 times 1. Okay, so we have 1 minus 4, therefore it's negative 3. The discriminant is negative. What does it tell us? Well, negative discriminant means there is no real roots. Okay. The shape. The shape of our parabola is that of the leading term. So shape is of x squared, the basic parabola. Opening opens which way? Yes, it opens up because the leading coefficient is positive. And the vertex. The vertex has coordinates. Let's follow the formula. Negative b, so we have negative negative 1, so it's just 1, over 2a, so it's over 2. Okay, now the second coordinate is negative discriminant, so in our case it's negative negative 3, meaning 3, over 4 times a, so it's just 4. Here we go. The coordinates of the vertex are done. So we are ready to graph it. 1/2 will be here and 3/4 approximately here. So our point, our vertex is at this place. Since the shape of our function is the same as the shape of the basic parabola, we'll go one step across, meaning up to here, and one up. So that's the next point. And one to the left, and one up. So that's the point. Okay, approximately here. Now 2 steps across, so it will be up to here, and then 4 steps up. 1, 2, 3, 4. 3/4 of the way in the square. And similarly to the left. 2 across, 1, 2, 3, 4 up to here. And then we can connect our points. So this is our parabola with the vertex at 1/2 and 3/4. That's 1/2. That's 3/4. Okay, we should do one more thing. We need to state the extreme value. Since the parabola has arms up, the vertex is its minimum. So the minimum value equals 3/4. The second coordinate of the vertex. That's our lowest value that the parabola can attain. We look at the y-axis, right? Let's see another example. This time, try to stop the video and do it on your own, and then resume the video to check your answers. So let's start with the discriminant. Discriminant delta equals b squared, which is 16 in our case, minus 4 times a, which is -1, and times c, which is -4. Altogether, we have 16, and we have minus, because of 3 negatives, right? Minus another 16. So 16 minus 16 is a nice happy 0, right? What does this tell us about the roots? We have one real root. Okay. What is the shape of this parabola? The shape is that of -x squared. So it's like basic parabola but upside down, right? Therefore, it opens down. And to find the vertex, we follow that rule. -b, so it's -4, over 2a, so over -2. And the second coordinate is negative discriminant, so it's still 0, over 4a, so it's -4. That means the coordinates of the vertex are +2 and 0. The vertex is exactly here, okay? And the parabola opens down with the standard basic shape. So 1 across, 1 down, and 2 across, 4 down. Here are the points. Let's connect them. That's our parabola. Okay, -1 here. Lastly, we need to state the extreme value. What is the extreme value in this situation? It's a maximum, right? The vertex is the maximum point. Therefore, we have maximum value equal to exactly 0, right? So, when the parabola is positioned upside down, the vertex gives us the maximum, and if it's positioned with arms up, the vertex is the minimum. Last example for this video, we need to do exactly the same with this function. So as before, let's calculate discriminant, which is b squared 4 minus 4 times a, which is 1/2, times c, which is -1. Altogether, we have 4 plus 2. So 4 plus 2 is 6. We have a positive discriminant, which tells us that we have 2 different real roots. Okay? The shape of our parabola is that of 1/2 x squared, which means our parabola will be wider. It opens which way? Well, the leading coefficient is positive, so it opens up. And to calculate our vertex, we follow the formula -b over 2a. So in our case, it's -2 over 2 times 1/2, which is really 1. In second coordinate, negative delta, so it's -6 over 4a. 4 times 1/2 is 2. Okay, so the vertex has coordinates -2 and -3. -2 is here, -3 over there. Here is our vertex with arms up, and we can follow this shape. That means 1 across instead of 1 up, we have 1/2 up, right? 2 across instead of 4 up, we have half away, so just 2 up. Here's our parabola, Let's connect it. Goes like this. As we see, we have these two real roots. Looking at the graph, we can approximate them. One root is between 0 and 1, and the other root is between -5 and -4. What about extreme values? We have a minimum. We have minimum value equal to -3. So the value, either minimum or maximum, is always the second coordinate of the vertex. This minimum value happens at -2, but it is equal to -3. Okay, well done.